All right, so we have our polynomial here we need to solve. We learned this before break, so this is a little review here. The polynomial we have is a quartic. The largest exponent is 4, so we would say it has a degree of 4. And we could sometimes solve that using a fourth root, but you'll notice it has this pesky x term in the middle, and we can't fourth root our equation when there's that x in the way. So we do have to solve this by factoring, and then once we get it factored, we can set the factors equal to 0 and solve them individually, like we did before the break. So let's start off by factoring. Our first step of factoring is always the greatest common factor. So both of these terms divide by 5, and they both have an x. So if you divide that out, you'd be left with x cubed plus 27. If you divide 135 by 5 and take the x away, equals 0. Okay, now this we call a sum of perfect cubes. So something cubed plus something cubed. Another way you could write 27 is 3 cubed. So we learned how to factor these on our very first test, and our formula that we came up with, if you have a sum of perfect cubes, two things being cubed, we factored it as a binomial times a trinomial, and the signs went plus, minus, plus. The first binomial went a plus b times the a value squared, and then a times b plus b squared. So if we use that formula over here, our a value is x. That's what's being cubed. And then our b value is 3. That is what's being cubed. So I'll say b equals 3. So if we write out this next step, we have our GCF in front, and we have our binomial and our trinomial. And if at any point I'm going too fast or you need to take a second to write things down, just pause the video and resume when you're ready. So if I follow our formula, I'll do a plus b, that's x plus 3, times a squared, which we said a is x, so x squared, plus a times b, or b times a, it doesn't matter, 3x, plus b squared, 3 squared is 9. So that completes the factoring. Now the way that we actually solve the polynomial is we set the factors equal to 0. So we set each of the factors equal to 0. Now if we start out with 5x, that's kind of our first factor. You can kind of think of x as x plus 0 if you'd like, but regardless, if you set 5x equal to 0 and solve for x, we do get an answer out of that. Anywhere there's an x, there's an answer. So 0 divided by 5 is 0. Now the next factor is x plus 3. So that one's nice and easy. If we set x plus 3 equal to 0 and solve for x, we'd subtract that 3 over and we get negative 3. So far we've gotten 2 answers. But you'll remember the total number of answers that you should get is the degree. We should get 4 answers. So the other 2 answers must come from this quadratic. Now you'll notice that if I set that equal to 0, I could solve by factoring, but you can't solve by square roots because of this x in the way. So we could try to factor it, but you'll notice that it doesn't factor. There are no factors of 9 that add up to 3. So the way that we learned to solve a quadratic that does not factor is we use the quadratic formula. And we learned that right before break. It's x equals negative b plus or minus the square root of the b value squared minus 4 times a times c all over 2 times a. So on our quadratic here, and I'm just looking at the quadratic, we have an a value of 1. So a equals 1. B is 3. and c is 9. So if you plug these into the formula, we get x equals negative 3 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to scroll down here. Sorry, this here. So if we simplify this, now the part under the square root we call the discriminant. That comes out to negative 27. You could type that in your calculator if you want. 3 squared minus 4 times 1 times 9 is negative 27 all over 2. And now we always simplify our square roots. So we know that negative under a square root is I. So I could call that I square root of positive 27 over 2. But we still need to simplify our 27. 27 is a perfect square of 9 times 3, like we did with our purple chart first semester, which is 3 square root of 3. And we do have that I in there, so I'll call that 3i square root of 3. So our final answer here would be x equals negative 3 plus or minus 3i square root of 3 all over 2. Now sometimes we can simplify this, but you'll notice 3 doesn't divide by 2, 3 doesn't divide by 2, so that's as good as it gets. You can just leave it just like this. Now that is two separate answers. It's negative 3 plus 3i squared of 3 all divided by 2, and it's negative 3 minus 3i squared of 3 all divided by 2. So we get two answers, but they are both imaginary. So 4 answers total, 2 real, 2 imaginary, adds up to 4. So graphically, you could graph this original problem, and it would only actually cross the x-axis 2 times for the 2 real answers that we got. That is all.